So the difference between these two graphs is that this one goes vertical and this one goes horizontal, and that the cart slows down, and after it has been pushed it slows down, and the plummet it is at constant acceleration. So something that these graphs have in common is that they both start at zero velocity.
We got position versus time for the cart and track, and with this one, it starts off at initial position here, and then with a push of someone's hand, it has initial acceleration here, and it goes out to a constant velocity, where the position is nearly identical between each point along the line all the way to the last point, assuming no friction. Yes. And it stops when you put your hand in front of it to stop it. And with the position with this time with the plummet, it starts with an initial position of 0, and then as soon as it drops, the force of gravity causes it to accelerate at a constant rate, and thus the position, when it ends up lengthening, it gets longer between each point from when you drop it all the way down, and the velocity is increasing at a constant rate. That's why it's a parabola.
To calculate the average velocity given a position versus time graph, all you need to do is draw a straight line from the start point to the end point and calculate the slope of that line. To calculate the slope of this line, you need to calculate the difference in y over the difference in x. To calculate the average velocity from a position versus time graph, you draw a straight line between the first and last points on the graph, and then you calculate the difference in rise over run, which would be delta x rise over delta t. Change in x, which is change in position, over change in t, which is change over time, will give you average velocity. To calculate instantaneous velocity, you have to draw a point along this curved line on the graph, and you have to create a tangent line. Once you have this line, you create a triangle and essentially do the same thing. Calculate delta x over delta t. This will be for instantaneous. What was instantaneous? This will be for instantaneous velocity. So this delta x e over delta t e will be equal to instantaneous velocity. To calculate the average acceleration from a velocity versus time graph, you do the same thing you do to find velocity from a position versus time graph. You create a straight line in between the first and last points, and you calculate rise over 1. This would be that's t, so this would be change in velocity over change in time. Change in velocity over change in time gives you average acceleration.
So for the plummet, on the velocity over time graph, the trend line represents a line that goes across the group of points going across. So around a central point of convergence.